Hi students, in this video we are going to see acidic strength of boron halides. Boron halides. So look at here. So boron trifluoride, boron trichloride, boron tribromide and boron triiodide. So we know that boron halides acts as Lewis acids. But we are going to find now which is strong Lewis acid and which is weak Lewis acid. Understand? So first let us look at the electronic configuration of boron, fluorine, chlorine, bromine, iodine. Okay, in order to understand in detail, let us see the electronic configuration. This is the valence electron configuration of boron. So 2s2, 2p1. Okay, okay. In the excited state, what would happen? In the excited state, you will get 2s2, 2p2. So in the excited state, the valence electron configuration of boron is 2s2, 2s1, 2p2. So now let us look at electron configuration of valence electron configuration of fluorine 2s2, 2p5, chlorine 3s2, 3p5, bromine 4s2, 4p5, iodine 5s2, 5p5. Isn't it? So you look at here 2s1, 2p2. Still you have one empty orbital there. So 2p orbital, under 2p you have 3 suborbitals, right? So 2 suborbitals are filled by 2 single electrons, remaining 1 orbital will be empty. That means boron is carrying an empty orbital. An empty orbital. Getting it? You look at here fluorine, chlorine, bromine, iodine. So all electrons are completely filled. 2s is completely filled. If you look at 2p except 1 orbital, remaining 2 orbitals are completely filled. So 2p5 means in 2p you have 3 suborbitals, 2 orbitals completely filled and 1 sub-p orbital off filled. Isn't it? That's why it is 2p5. So from fluorine to iodine, number of electrons are same in the valence electron configuration, but orbital size is different. This is 2s orbital, this is 3s orbital, this is 4s, this is 5s. This is 2p orbital, this is 3p orbital, 4p orbital, 5p orbital. When you are moving from fluorine to iodine, size of s and p orbitals are increasing gradually. Got it. Now let us come back to these halides. Now I have written here elaborate structure of boron trifluoride, boron trichloride, boron tribromide and boron triiodide. Okay. So already we discussed that boron is having empty orbital there. Empty orbital there. So fluorine has 7 electrons in the valency. Boron has 7 electrons in the valency. So one single electron, 3 lone pair of electrons. The single electron will participate in making one bond like this. Okay, the single electron in fluorine participates in bond formation of this, and remaining 6 electrons will be like 3 lone pairs. Here also same thing. Fluorine is having 7 valence electrons. 1 electron will participate in making this bond. Remaining 6 electrons will be like 3 lone pairs. 3 lone pairs. Everywhere the same thing. Fluorine also having 7 electrons. 1 electron will participate in making a sigma bond. Remaining 6 electrons like 3 lone pairs. Bromine also follows same thing. Iodine also follows same thing. Okay. Now how we are going to predict acidic strength of these acids, and which one is strong Lewis acid, which one is weak Lewis acid, isn't it? So we know that electron deficient compounds are Lewis acids and electron rich compounds are Lewis bases. Okay, so boron is having, everywhere boron is having empty orbital, therefore boron halides are Lewis acids. Now which one is strong, which one is weak, that's what we have to compare now. Yeah, so these are very important. The comparison is very important. Regarding this, the question is given in previous NEET exams and IIT JEE exams. Got it. So now let us see here. So we know that there is an empty orbital present at boron, and here fluorine is carrying 3 lone pairs, and it is able to donate, since it is having 3 lone pairs, it can donate at least 1 lone pair to the empty orbital of boron. And where is that lone pair is located? The lone pair present in 2p orbital, because fluorine has 2p orbital. The lone pair present in 2p orbital. Which orbital boron has? The empty orbital of boron is 2p. Here it is 2p, here it is 2p. So 2p orbital of fluorine and 2p orbital of boron will have good overlapping, because the size of orbitals are same. The size of orbitals are same or equal. That's why the overlapping of this 2p orbital with this empty 2p orbital will be good. And they makes p pi bond. P pi bond. It is making a pi bond through the overlapping through the overlapping of 2p orbital of f orbital, 2p orbital of fluorine, and empty 2p orbital of boron. Okay, and making a bond. That bond is labeled as p pi bond. And here the overlapping between these two p orbitals is very strong because there is no size compatibility is there. Both are having same size. That's why this 2p can interact strongly with this 2p. Okay? Yes. Then what would happen? The empty space around boron will decrease. When overlapping happening, the lone pair will try to enter into the empty orbital, isn't it? Then empty orbital will be filled by the lone pair up to some extent. Then its Lewis acidic nature will decrease. So Lewis acidity means what? You should have empty orbitals or electron deficient compounds or Lewis acids. So when you are donating lone pair to the empty orbital, the empty space or empty orbital of boron will be filled up to some extent by that lone pair. The acidic strength will decrease. Got it? Here what would happen? Here also the back bonding will take place. The p pi bond will take place. Here also p pi bond will take place because there is empty orbital present at boron. There is a lone pair at chlorine, but the lone pair present in 3p orbital, isn't it? So where is the electrons in p orbitals? No, 3p orbitals. So this is 2p, this is 3p. The lone pairs present in 3p orbital. So boron is having 2p orbital here, chlorine is having 3p orbital. So 2p, 3p, size is mismatched. Since the size is not compatible for each other, the interaction or overlapping of these two orbitals are less. The p pi interaction will be less. The interaction happens, but the interaction is not greater as we have seen in case of BF3. Okay? Yes. So let us come here. So here bromine is having 4p orbital. It is 2p orbital. Iodine is having 5p orbital, and it is bromine is 2p orbital. When you move from fluorine to iodine, the size of p orbital is increasing. As you increase the size of the p orbital, the interaction between the boron empty orbital and the p orbitals will decrease because the size is not compatible. Here the interaction is good because this is 2p orbital, this is also 2p orbital. So the interaction, the overlapping between orbitals will be greater and larger. But the overlapping of the extent of overlapping will be decreased here because this is 3p orbital, 2p orbital. Overlapping happens, but that doesn't happen as it happens for the BF3 molecule. Understand? So same thing. So when you're moving from BF3 to BA3, the overlapping between p orbitals of halogen and p orbital of boron will decrease because the size of p orbitals gradually increasing from fluorine to iodine. Here also back bonding happens. P pi bond happens. Here also p pi bond happens. But the interaction between these orbitals are very less because the size is not compatible. This is 2p orbital, smaller in size, 4p orbital, larger size orbital. This is 5p, so it is very larger than this. It is like 2p. If we have same kind of size, the overlapping between two orbitals will be good. If you have different size, the overlapping is less. When the overlapping is less, okay, the empty orbital of 2p, the empty 2p orbital of boron will be occupied by lone pair is very less because the overlapping is less. Since overlapping is less, okay, the lone pair doesn't enter completely into the empty orbital of boron. But in this case, almost the lone pair completely fills empty orbital of boron. That means, so 2p orbital almost will be filled by the lone pair of the fluorine. But here it is not like that. Since the overlapping is very less, the lone pair doesn't enter completely into the empty orbital of boron. So where you are having more empty space, here or there? Yeah, here we are having more empty space because overlapping is less. Here you have less empty space at boron. If you have less empty space, that will be least Lewis acid. If you have more empty space, that would be strong Lewis acid. Understand? So now how you arrange acidic strength of these halides? Ba3. Ba3 is a strong Lewis acid. Then BBr3. So which is now strong acid. Then BCl3, which is strong acid than PF3. So this is the decreasing order of Lewis acidity. Lewis is the decreasing order of Lewis acidity. So Bi3 is strong acid because you have more empty space or more empty space there at boron. So a BF3 is weak Lewis acid because the empty orbital or empty 2p orbital at boron is completely means almost it is filled by lone pair of the fluorine. Therefore, BF3 is weak Lewis acid and this is strong Lewis acid. This question has come many times in NEET exam and IIT also. Okay, so it's very important concept. If you have again any questions regarding this, you can type in comment box so that I can reply you back. Okay, so thank you for watching.